In this video, we will explore how to determine the equation of a sinusoidal graph, such as the one shown here. To do this, we need to determine the values of A, B, C, and D from the characteristics of the graph. First, determine the maximum and minimum values. This will help find the midline and the amplitude. The maximum value of the function is 2, and the minimum value is -8. Use the midline formula to determine the location of the midline. Think of this formula as averaging the maximum and minimum values. Insert the values of the maximum and minimum into the formula and simplify. The midline is at y equal to -3. We know that D has the same value as the midline, so D is equal to -3. Next, determine the amplitude of the graph. This is determined by using the amplitude formula. The amplitude is 5. You can also calculate the amplitude using the distance from the maximum to the midline, or the distance from the minimum to the midline. Notice that the amplitude is always positive. The A value is equal to the amplitude, so A is equal to 5. Next, determine the period of the graph. A period is the horizontal distance required to complete one cycle. Here you can see 4 cycles of the graph, or 4 periods. Each period has a length of 12.5. The B value is related to the period by the equation period is equal to 2 pi divided by B. This can be rearranged as B is equal to 2 pi divided by the period. Since the period in this graph is 12.5, the B value is approximately 0.5026. Finally, determine the horizontal translation to find a C value. So far, we haven't specified whether we are using a sine or cosine graph. In fact, it is possible to write an equation for this graph using either sine or cosine. Suppose we choose to write a cosine equation. A cosine equation with a C value of 0 will have a maximum at x equals 0. In this case, the maximum occurs at point 0,2. Unlike the other characteristics that lead to one measurement, there are many different horizontal translations from the red graph that will give the blue graph. For example, we can move the red graph to the right 6.25 units, or to the left 6.25 units. The C value is equal to the horizontal translation. Moving right gives a C value of 6.25, and moving left gives a C value of -6.25. We can use either of these values of C, as well as many other C values, to complete the equation of the function. As mentioned before, it is also possible to use a sine equation to represent this graph. A sine equation with a C value of 0 will cross the midline at x equals 0, with the graph increasing. Again, many different horizontal translations are possible. We can move the red graph to the right 3.125 units, or to the left 9.375 units. The C value is equal to the horizontal translation, so moving right gives a C value of 3.125, and moving left gives a C value of -9.375. We can use either of these values of C, as well as many other C values, to complete the equation of the function.